Hi, good day and welcome to my next video on paper 3 questions for CXC mathematics. Now this video is going to be a little bit different. I'm not going to actually show the past paper and do the past paper. Instead, what I did, I went through a lot of the paper 3 questions, and what I did, I tried to kind of look for a pattern of the type of questions that actually come. And the conclusion is there is no difference between the theory in paper 3 and the theory in paper 2. Paper 3 is just 2 questions from paper 2. There's 2 extra questions. However, I did notice only certain type of questions come over and over and over. So if you're watching this video, if you're a person writing paper 3, you can relax. If you study for paper 2, you will automatically be prepared for paper 3. And of course, if you are a student who does not have to write the paper 3, still watch this video. Like I said, it's the same theory and the same type of questions. But I'm still going to do it, and because I'm sure it's just relieve the anxiety that a lot of people have with paper 3. They think it's different. I'm going to show you it's not different. So one of the most popular questions, for some reason, always involves some food item. And a lot of times, it's pizza. Here's what we have. We have a situation where we have a small pizza and it has some dimension on it. You see a 7 centimeters. And then you have this slightly bigger pizza with a dimension here of 20. Apparently, this whole pizza here, the smaller one, if you want to buy the whole thing, you can buy the whole thing for $8.95, the whole small pizza. The bigger pizza has a slightly different deal with for it, right? You cannot buy the big pizza, apparently. You cannot just buy the whole big pizza. Instead, right? Well, you could, but instead they price it by the slice. So this pizza has 5 slices. 1, 2, 3, 4, 5. You're looking at the green lines. And each slice costs $7.95. So, which one is the better deal? That is what the examiner usually asks in the paper 3 questions. Which one is the better deal? Alright, so pizza might be kind of complicated, but let's talk about something you are more familiar with first, something easier. And then we could possibly, apply to this. Let's take jelly beans. Let's say I have 2 containers of jelly beans. One has 4 jelly beans, one has 5. 1, 2, 3, 4, 5. This one, the whole container, costs $6, and this one, the whole container, costs $7. Which one is the better deal? Let's do some calculations. To figure out which one is the better deal, we usually take the cost and divide it by the amount we have. So take down that formula. You're going to need the formula. It's cost divided by amount. And when we divide it, the smaller the answer, the better the deal. So that's the rules here. So take this down, write it down, guys. Let's work it out for this container here. For the one with 4. To work out the deal here, I'll just put D for deal, right? What's the cost of this one? $6. And what's the amount of jelly beans we have? 1, 2, 3, 4. So that means if we divide the 6 by the 4, we will get 1.5. Well, in this case here, we are dividing the cost, which is in dollars. So the answer will be $1 and, sorry, I should put it on the side here. The answer would be $1.50 per jelly bean, JB. So that means for each jelly bean, we are paying $1.50 over here. Let's work it out for the other container. For this one, we have to work out the deal. We have to take what? The cost. The total cost is $7. And what's the amount this time? 1, 2, 3, 4, 5. So if we take 7 and divide it by 5, we will actually get 1.4 or $1.40 per jelly bean. Let's double check that. 7 divided by 5. Right. To figure out which one is the better deal, we have to choose the one with the smaller answer. Remember, the smaller the better. When you work out this form, when you work it out using this formula, isn't 1.4 smaller than 1.5? Great. So this one is the better deal because you're only paying $1.40 for each one. This one you're paying $1.50 for each one. So I would buy this container. He is the better deal. Right. So jelly beans, like I said, it's easy to understand. But what about, you see, this amount is what is confused students. When you're measuring jelly beans, to figure out the amount, you just have to count. But suppose you have juice. Juice is a liquid. How do you measure the amount of juice? You can't count the amount of juice. You measure the amount of juice by volume. So if it was a pack of juice, the amount would be like 250 milliliters or 250 centimeters cube. And you'll notice that a lot of soft drinks, when you buy it, they have the volume written at the bottom. The volume might be in what? Milliliters? Well, most of the times it's milliliters, but milliliters and centimeters cube can also be what? Used. But what about a pizza now? How do you measure the amount of a pizza? Say you have one pizza and somebody asks you, hey, what's the amount of pizza you have? You might be stumped, you might know what to say. But the amount of a pizza, but for CXC purposes, is the area. So if somebody asks you, hey, how much pizza do you have? It might seem weird, but you could say, I have a pizza with 400 centimeters cube, with an area of 400 centimeters squared. Might seem weird, but you're being very accurate. So, for the pizzas, we are going to calculate the area for each one, right? So I'm going to move this formula across here. The D for, let me write it back out, yes. I know sometimes you actually just need to see the full formula in front of you. Is the cost divided by the amount. But I already need the space here. So let's calculate the area of this pizza. So I'm just going to call this pizza A, pizza B. For pizza A, the area is pi multiplied by radius squared. Remember, the radius is from here to here. Okay? Alright, so the radius is 7. Now I know some people have an issue with pi. Pi is 22 over 7. So if you can't find the pi button on the calculator, you just have to press 22 divided by 7 and then multiply by the radius squared. So pi, and how much is the radius? 7, and then you have to square it. Now I'm just talking from experience. A lot of students mix up squared and multiply by 2. 7 squared is 7 multiplied by a next 7. Don't ever, and this will be what, 49. Don't ever make the mistake and say 7 squared is 14. I know some of you are watching this video are guilty of that right now. You made the mistake and said 7 squared is 14. 7 squared is 49. So this is pi multiplied by 49. Let me work out that on my calculator. Pi multiplied by 49. I am going to get roughly 1, 5, 3, 22.94 centimeters squared. If you had root 22 over 7 and worked it out, you would have get 154. Up to now, I'm not too sure why pi and 22 over 7 gives you slightly different numbers. I really don't know. So I'm just letting you know that if you get 154, don't make it a big issue today. If you plan to use pi, like press the pi button, you have to write that on the paper. If you plan to use 22 over 7, you have to write 22 over 7. What I'm trying to say is, you can't write pi in the exam and then type in 22 over 7 on the calculator in secret. The examiner will get confused. So anyway, this is the amount of pizza A. If somebody asks me, hey, what's the amount of pizza A that I have? I would reply 153.94 centimeters squared. And they would look at me funny, but whatever. Let's work it out for the large pizza now. Pizza B. Let me use a different color film so you can see the difference. For pizza B, right? To calculate the area, it's pi multiplied by radius squared. I'm just going to use the pi button. I'm trying to trick you in the exam here. I made up my own question here. You see how in this one the radius was 7? The radius is from the center to where? The circumference. Over here, it's from one end to the center to the other side. So this 20 is actually the diameter. And I put them side by side on purpose because I did it like this. So a student, you know what he would do? He would say pi multiplied by 20 squared. But this formula requires radius. Radius is half the diameter. So it will be pi multiplied by 10 squared. The radius is actually 10. Watch the questions carefully. I'm not saying all examiners put tricks in it, but they have to put things to challenge you. That's the purpose of an exam. Okay, so watch it carefully. I guess that's the moral of the story. Let's work this out. Pi multiplied by 10 squared. Pi multiplied by 10 squared is 314. If we round it off, 16 centimeters squared. So this is the amount of pizza B and this is the amount of pizza A. It's time for us to work out the deal. So this is going to be the deal for A. I'm going to do that working up here. I'm going to put a line here. And when I reach down here, I'm going to work out the deal for part B. The deal for part A is the cost of the entire pizza. So the entire pizza is $8.95. And what's the amount of pizza A that we have? 153.94. That's the area. When we divide this, I need a space here for something just now. Divide this, 8.95 divided by 153.94, and you will get a very small number, but I'll explain what the very small number means just now, how to interpret it. 0.058, and this answer will be in cents per centimeter squared. That's a pretty small number. So that means every centimeter squared that you eat out of this pizza is costing you this amount of money. $0 and 0.058 cents. Seems cheap, right? That's for every small bite that you take out of the pizza, you're paying for each piece as you eat it. Let's do it for part B. To work out the deal for part B, we need the cost. But what's the cost of the entire pizza? It has 5 slices. 1, 2, 3, 4, 5. And each slice costs $7.95. So if I want to buy the whole pizza, it will be $7.95 multiplied by 5. Because I need all 5 slices to make the whole pizza. And what's the amount or area of the big pizza, of the whole pizza? 314.16. Let's divide this. $7.95 multiplied by 5 divided by 314.16. And I get 0.127 cents per centimeters squared. Which number is smaller now? This one. So that means, because for this one you're paying 0.127 cents. Remember, the better deal is the smaller of the two numbers. So that means A, having a smaller number, is the better deal. Okay? And you just have to write a sentence for the examiner. A is a better, here's the sentence, right? So you might have to rewind the video. A is the better deal because you are paying less for every centimeter squared. Per means every, or for one. So, and once you have the two answers, like you were able to show the calculations that the cost of this one is less than this one, then you write the sentence that I just quoted. Okay? Not quoted, just said, sorry. Alright. Now, I just I not only want to do this question, I want to show you other things in this question in case it comes in the exam, right? So, I'm not going to do this video halfway for you guys. I'm going to make sure I do a proper video. So when you finish with this long video, you're very comfortable with paper 3 questions, right? So that's my aim today, right? To make sure that you get a proper video explaining every question from different angles. That is my aim today. All right. Students normally mix up area of a circle and circumference of a circle. The area of a circle, write down the formulas, and guys, just don't watch this video. You gotta get a pen, a paper, a calculator, and do everything with me. Otherwise, you're not gonna learn as much. The area of a circle is pi multiplied by radius squared. You just saw this. Or, some people don't like to write the pi. So, pi and 22 over 7 is the same thing as pi. So this is the area of a circle. This is also the area of a circle, right? The circumference of a circle is the distance along the circle or around the circle. Look at the slight difference in the formulas. There are two formulas. You can take pi and multiply it by the diameter, or take 2 multiplied by pi and multiply it by the radius. I understand why students get confused. Because if you look at area, it has a pi, a 2, and an r. Circumference, the second formula, has a pi, a 2, and an r. But the 2 here is a squared. Over here, the 2 is a multiply. Okay? So, when it comes to finding the circumference of a circle, this is the one that I usually use. Because this one has the diameter and it's less similar to this one. So I'm not going to mix it up now. So circumference is pi by diameter. And remember, the diameter is the long one. The diameter is twice the length of the radius. So let's work out the circumference of A. So let's say the examiner asks you to find the circumference of A. CIR, I'm just abbreviating it. Let's find the circumference. Circumference is pi multiplied by diameter. Pi is just a button on my calculator. How much is the diameter? Remember, this is the radius. The diameter is twice the radius. So the diameter is actually 14. Let's work that out. Pi multiplied by 14 is 443.98 centimeters, not centimeters squared, because it's just a distance around. For this one, if I ask you to find the circumference is pi multiplied by diameter. Pi is just a button on my calculator, and the diameter, you were given the diameter. The diameter is what? 20. So it's just pi multiplied by 20, which is 62.83 centimeters. Okay, guys? So I'm just making sure the camera is still on and it hasn't cut off as yet. So for circles, we discuss area, we discuss circumference, right? And of course, we did a little bit of finding out which one is the better deal. I wonder what else the examiner can throw on us. Let me see. Let me erase this. You know how to find the area of a full circle. Alright, so let me draw another pizza here for you, since we're on circular food. So I have a next pizza here, right? Let's say the radius of this pizza, I'm going to put a dash for a reason, is 13 centimeters. That's a pretty biggish pizza, right? And I ask you to find the area of the pizza, but somebody has taken a bite out of the pizza. They have taken, well, let me not draw it like a quarter. They have taken this part of the pizza and eaten it. So a piece of the pizza is missing, and we only have this portion here. That is not a full circle. It is not. Okay? But I'm just going to write the 13 here. From here to here will be 13. Because if you spin this like a windshield wiper, if here is 13, from the center to any point will also be 13. Right? So I'm just erasing this just so you can see it better. And I ask you, first question, to find the area of this shape, which is not a circle. Okay? This is actually a sector, right? A sector is piece of a circle, like it's like a pizza and somebody takes a slice. Let us adjust the formula for the area of a sector. The area of I just put a and a small s here, so area of a sector. The area of a full circle is pi multiplied by radius squared, but that's for a full circle. When it's a sector, you have to multiply by theta. I'll explain what theta is just now. And you divide it by 360 degrees, because a circle has 360. Obviously, this formula doesn't make much sense yet if you're not familiar with it, so I need to do an example. I need to put numbers into it. Whenever the examiner asks you to find the area of a sector, he has to give you the angle inside the sector. So let's assume the area is 120 degrees. So if we take our protractor and we measure this, we'll get 120 degrees. And we know the radius is 13. So let's calculate the area of this sector here. Pi multiplied by 13 squared, because that's the radius. Don't forget the squared. Theta is the angle inside the sector, right? So it's 120, and then we divide it by 360. 360 comes with the formula. It will always be in the area of a sector formula. So pi multiplied by 13 squared multiplied by 120 divided by 360. See if you can work it out before me. Pi multiplied by 13 squared multiplied by 120 divided by 360. And tell me if you get this answer. 176.97 centimeters squared. Please note I am using the pi button. If you use 22/7, it will be slightly different. It might be 177. It will be slightly bigger. Don't let it bug you. Whatever you plan to use, you have to write it on the paper. Don't keep it upstairs in your imagination. You will confuse the examiner. Alright, so this is the area of a sector. Here's what I'm going to do now. I'm going to adjust this question. Let us find the perimeter of this shape now. Perimeter. Perimeter means the distance around the shape. So this is going to have to deal with somehow with the circumference of a circle, partially. Remember, the circumference is the distance around the circle. The circumference, I'm going to use C, for a full circle is pi multiplied by diameter. If it is piece of a circle, you have to multiply by theta divided by what? 360. So for this one, for a full circle, right, we know the diameter and we adjust it. Let's calculate for this, sorry, I need this here. Let's calculate the circumference of if this circle was full. If, right? Sorry, we're going to calculate the circumference of this. So to find the circumference of this shape here is pi. How much is the diameter though? The radius is 13. That means the diameter is twice the amount. So the diameter is 26. How much is the angle in the sector? 120. And then we have to divide it by 360. Now there's a trick in this question that a lot of students normally fall for. So it's pi multiplied by what? 26 multiplied by 120 divided by 360. And we're going to get roughly 27.23 centimeters. But here's the trick. That's only this part from here to here. That's the black part here. They asked for the perimeter of the shape. Remember, if it's the perimeter of this shape that we want, it's not only the black line. We have to count here and here. Because if somebody is running, they run, and when they reach here, they run along the radius, and once they reach here, they run over here. So this part alone is the 27.23 centimeters. Here's 13 and here's another 13. Why? Because here is a radius and here is still a radius. So that means you have to add 13 and a next 13 to get the total what? Perimeter. So it's 27.23 plus 13 plus a next 13. And I am getting the perimeter of this shape. P for perimeter is 53.23 centimeters. Alright guys, so this is the best I could have explained the first question. I took inspiration from the paper 3 questions involving like pizzas and circular objects, and I added in my own questions, I guess, on how the examiner could spin it to try to what? Well, not fool you, but to test you. That's a better word there. Alright guys, so now on to question 2. I already need a drink of water. Just give me a few seconds, right? Okay, so we still have 1 second. Question 2. If you go through the past papers, you will see a ton. Like almost every past paper has something to do with a matrix, a matrix. What's going to happen here? It normally comes the same exact way every year. That is from what I understood, what I noticed. Here we have a football match. And apparently, if you win the game, you get 3 points. If you draw the game, you get only 2 points. And if you lose, you're getting 1 point. That's just the rules of this competition. There are 2 teams, Team A and Team B. Team A won 4 games, they drew 6 games, and they lost 2 games. Team B won 3 instead, drew 8 games, and lost only what? 1 game. And the examiner will ask you to put this in a matrix form. And actually in these questions, he's pretty nice to you. He kind of goes through step by step, and part A will tell you do this part, and part B will tell you to do this part, so he gradually builds you up, right? So let me break it down here. He will ask you to write the score system. This is the score system. 3 for winning, 2 for drawing, 1 for losing. And he will tell you to put it in a 3x1 matrix. Now a 3x1 matrix means this is the rows and this is what? The columns. It has 3 rows, 1, 2, 3, and 1 column. Usually the 3x1 matrix, this contains things like points and costing. Now this question has nothing to do with costing, but I've seen questions where they have a hardware, and the hardware is selling things like hammers, chisels, and shovels, or something like that. And of course, each of those 3 items has a cost associated with it. So things like points and cost go in the 3x1 matrix, and you just always have to write it vertical. So you see this note here, things like points and the costs will go in the small matrix, the 3x1 matrix. So put the winning points first. Winning is 3. Drawing is 2, and losing is 1 point, right? So win, draw, lose. And the examiner will tell you that needs to be a 3x1 matrix. Then he will tell you to write a 2x3 matrix. 2x3 matrix has 2 rows, 1, 2, and how much rows? How much columns? 3. 1, 2, 3. When these are the things being measured. Now you have team A and team B, and this is what they got. You are measuring the amount of wins, the measuring amount of draws, measuring the amount of losses. When you're writing this one, it goes horizontal. So you're going to write the information for A on top and the information for B underneath. Now you have to be careful. If the wins come first and the draws come second and the losses come third, when you're writing it, it has to be like this: win, lose, draw, or first, second, third items. So team A, 4, 6, and 2. This 4 is associated with this 3 because this is the points for winning. This here is the points for what? Drawing, and this is the points for what? Losing. And you're doing the same thing for B. 3, 8, 1. So this will be like part A of the question and part B of the question. And then he will say, hey, calculate using a matrix method, right? Because I know you can get out this without using a matrix method, but he would specifically say, using a matrix method, calculate the amount of points for team A and calculate the amount of points for team B. So let me get my duster and show you how to take a 2x3 matrix and multiply by 3x1. So I need a little space on top here, right? Always remember, if you're confused, don't watch the rest of the video. Rewind it, make sure you get everything I just said here clean, and then move on, right? Alright, oh, by the way, this is matrices, I guess you realize. Remember, if this is like the first time to the channel and you want to review the whole of matrices, my YouTube channel has every single thing on matrices. All you have to do is go on YouTube, go on the search bar, type in I love lessons space and the name of the topic, which is matrices, and you will see about 9 or 10 videos explaining matrices from the beginning, from the simplest thing, and gradually building up to the complex topics. You have to go through all of those things in order to understand this better. There's no shortcut to maths. I know a lot of people just want to watch one video, get an idea, and hope to pass the exam without doing plenty work. It's not going to, most likely, it's not going to work out for you. It takes a lot of hard work and it's a gradual process. Okay, guys? Now, I know a lot of people don't want to hear that, but that's just the truth. So let's multiply this matrix by this matrix. What you need to do, you see these two numbers, they will swing up to the top. So over here now you have 2 and 1. So 2 of them swing up to the top. How much numbers do you see here? 3. 1, 2, 3. Here's the thing. Anytime you are multiplying two matrices, you have to make sure the two inner numbers are the same. The two outside numbers tells you how big your answer is. So the two inner numbers are the same, great. And my answer has to be a 2 by 1. A 2 by 1 matrix has two answers, one on top and one underneath. 2 rows and 1 column. When you're I'm going to continue with the multiplication now. So when these two numbers swing up to the top, you see these 3 numbers on top, they walk across. So that means the 3 will end up on top here, the 2 will end up on the 1, because the 3 of them just walk across. You see these 3 numbers here that just walk across? Photocopy it over here now, over these 3 numbers, 3, 2, and 1. Each pair of numbers, you're going to multiply them. So I just put 1 multiply, but we're multiplying all of them. 3 by 4 is 12, 2 by 6 is 12, 1 by 2 is 2. 3 multiplied by 3 is 9, 2 by 8 is 16, 1 multiplied by 1 is 1. To get the answer on top, we add up all the top answers, all the top products. 12 plus 2 will give me 26. 9 plus 16 plus 1, it just so happens we also get what? 26, right? It's just coincidence that both answers are the same. The top answer is the total amount of points for team A, and the underneath number is the total amount of points for team B. Right? And this is the general way the matrices questions, from what I've noticed, come in question in paper 3. That's my noticing that. I think that's the word go. Alright guys. So next question. Oh Lord, it's a long video. Get some water and I'll be right back. Push this across. Alright, so the next question seems to be a cylinder question. Alright, so I can push it a little more here, make sure everything's on the screen, nothing is blurry. Alright. Okay guys, now, I just wanted to mention that of course I'm doing a lot of practice questions here, but if you want to do extra work and really do all the topics in detail, you can always contact me for online Zoom classes. I have a lot of classes I'm running. If you want to fall into one, you can always find my number in the description below. Unfortunately, the live Zoom classes and my official classes is only for persons in Trinidad and Tobago. However, the YouTube channel is available to anyone in the world, obviously. Okay? So, here we have a cylinder, and the cylinder has fallen over on its side. Now this is a closed cylinder. What do I mean by a closed cylinder? It means there's a cover here and there's a cover here. So if I put water in it and I turn it so, no water can fall out. It's closed. I want you to find the volume of this cylinder. So how do you find the volume of a cylinder? Now, I just want to give you a general formula to find volume. Suppose it's not a cylinder. Suppose it's a cube or a cuboid. or a shape that has what? A triangle at its face. Here's the thing. Whenever you want to find the volume, VOL for volume, of a uniform shape, I'll explain what a uniform shape is just now, don't worry. All you have to do is take the area of the face. So what you have to do is just look at the face, ask yourself, what shape am I looking at? And you find the area of the face, and you multiply by the length. But obviously if you turn the cylinder this way, the length will be the height. So length and height is the same thing. What is a uniform shape? Let me see if I can get an example of what a uniform shape is. I think I have one here. Alright, I have a little paint can here. So I have a paint can. This is a uniform shape because look at the face, right? The face is a circle. And right throughout the shape, you notice the thickness is the same. If I slice here or I slice here and you look at it from in front, it's going to be the same exact size of circle. It's not only for cylinders, you know. Let me get oh, there's a rug. Right. Here we have a box, a cuboid. You notice you have a rectangle here. If I cut the cuboid here, or here, and you look at it from in front, the size of the rectangle will remain the same. So in other words, the thickness remains the same or uniform throughout the shape. Let me show you what is not a uniform shape. Let's use some things that I have here. This bucket, look at it. The bucket is bigger in front, but behind it's slightly smaller. So as you go this way, the thickness slightly what? Decreases. This formula is only for uniform shapes. So for this shape, I cannot use this formula. It's only for uniform shapes. And I know what you're wondering. What would happen if the examiner gives me a shape which is not uniform? Don't worry. When we reach that question on that side, I'll handle that. Checking the camera one more time to make sure it's working. Alright. So let's look at the face here. Pretend you have somebody standing on this side of the barrel. And he's looking at the face. From the front view, he will see a perfect circle because he's looking this way. From here to here is 94. So that means from here to here is 94. So that means the diameter of the circle is 94 centimeters. To find the area of a circle is pi multiplied by the radius squared. The radius, remember when we did it across, so is half what? The diameter. Where did I put my calculator? So we need to find half of 94. 94 divided by 2 is 47. So to find the area of the face is pi multiplied by 47 squared. So that's just the area of the face. And once we get the area of the face, to get the volume, we just multiply by the length. The length is 182 what? Centimeters. So let's work this out and we will get the volume of the cylinder. Pi multiplied by 47 squared multiplied by the length, 182. And we get a really big answer. It's 12,63039.63 centimeters what? Cube. Make sure you see it on the calculator and double checking it. 1263.03. 1263.039. Yep. That there is the volume of the cylinder. Alright, so how can this question come different now? Suppose they ask you to fill this with water, but they tell you that they turn it this way. So we're going to turn it this way. Upright. It's the same barrel or cylinder. From here to here is still 94, and the height is still what? 180, 182, yeah, 182 centimeters. Okay, let's double check in everything here, 182. Here's the question now. They say you're going to fill this with water, but they're only going to fill it up to here. Now, I'm not saying that's halfway up or whatnot, right? But let's say they fill it up to, and the water that they throw inside here has a volume of 84050 centimeters cubed, right? So they did not fill the barrel. Instead, they throw a certain amount of water, and this is the volume of water in the barrel now. Obviously, the barrel is not filled all the way up to the top. It's filled to a certain height with this water in it. And guess what the examiner is going to ask now? What is the height of the water in this tank? Let's do some calculations for this. Let's do some calculations. Right. In this case, they gave you the volume. Remember, from here to here, it's still a uniform shape. Same thickness, same thickness, same thickness, same thickness. Now they gave you the volume. The volume is 84050. The area of the face is still a circle, so it's pi multiplied by what? The radius squared. How much is the radius again? The radius is half the diameter. So 94 divided by 2 is 47. So pi r squared. And now we want to find the length, but the length is really the height. Remember, I tell you, if you turn it so, the length just becomes the height. So we're trying to find the height here. This is the face area multiplied by the height. Let's work this out and solve for h. Pi multiplied by 47 squared, pi multiplied by 47 squared is 6939.78 multiplied by the height. That's when you work out this part, you get this crazy number. This crazy number is being multiplied by the h. So when you throw across a multiply, guys, you'll remember what you get? A divide. 6939.78. Let's divide these two things. 84050 divided by 6939.78. We're getting the height to be 12.11 centimeters. So the height of the water inside there is 12.11 centimeters. Okay, great. Guys, I think I'm going to hold it off there at question 3. I think I need I'm going to make a next video, and then we're going to be doing what? Question 4, then I'll have a 5, 6, and 7. My voice is getting a little hoarse. I think I'm getting too tired. So I'm going to take a rest. I'm going to come back, and I'm going to do part 2 to this exercise. Thanks for watching. And guys, don't forget to share and subscribe. A lot of people can use this information here. And guys, please remember, don't watch these videos alone. Make sure and do the background theory first. That will help you in all the papers. Paper 1, paper 2, paper 3. Background theory is essential. Don't try to go from zero to hero in one video. It won't happen. Take care, guys.